All right, guys, so 8-1. We're going to talk about polar coordinates, how those relate to rectangular coordinates, plot some points, converting between the two, just kind of the basic intro to how polar coordinates work. So first, you guys are used to plotting an XY point on the rectangular coordinate grid. Like, you're used to going, okay, this dot, I know that's over however many units on the x-axis and up however many units on the y-axis. Like, you've plotted points like that for years. What we're going to do now is start plotting on the polar coordinate system, which is this weird looking circle graph, okay? You have an r and a theta. What does r usually stand for? Radius. Still does. That's what we're talking about here. So it's a distance out. So like if I plot, let's say this point right here, that r would be 1, 2, 3, 4. Okay, because that's the radius, how far out I am from the center. And then the angle, it's talking about how far from this initial x-axis have I traveled to get to that point. This is still 90 degrees up here, okay? 45 didn't get marked, that would be in the middle. So it looks like 30 degrees to me. So that point is the point for 30 degrees, or you might see it for pi over 6. Okay? But it's a radius and an angle now that we are plotting. It'll take your brain a little while to kind of wrap itself around that. And you can label that point in a lot of different ways. Let's come down here. So we've got the point 6 pi over 4. I'm going to go ahead and draw in like where the pi over 4 would be. Put a line in there. Ooh, maybe I am. Does that make sense to you guys right in the middle there? Yeah. Okay. All right, so how would I plot 6 pi over 4? What do I do? Yep. And then I go around. How much of an angle? Yes, yeah. So you just count out 6 rings. 1, 2, 3, 4, 5, 6. Travel around pi over 4. There is your point. We can name that point in a lot of different ways. If I stick with a positive 6, so traveling out 6 on the positive axis first, I could then travel by a negative angle and be at negative 7 pi over 4. So negative angles are still a thing. That just means you're traveling backwards around the circle or around the grid here. If you guys remember coterminal angles, I could also go more than once around the circle. So this could be like 6, 9 pi over 4. You can also start with a negative radius. So if I started with negative 6, instead of counting out to the right, where do you think I'm going to count first? Yeah, so I'm actually going left 6. So 1, 2, 3, 4, 5, 6. So I'm kind of starting from where that X is over there. It's going to be a different angle to get to that blue dot. If I want to go positive, guys, how far would I be going to get there? Yeah, 5 pi over 4. Good. Or if I start with that negative 6 again, so starting there over where the X is, part of the X. What if I travel a negative angle? How far do I have to go to get there going a negative direction? Yeah, negative 3 pi over 4. So being comfortable with your unit circle is going to be helpful when plotting these points, okay? If you just see it and you know your circle well, you can just list out the different points for it. That's great. If you want to have a formula to follow for that, we've got a couple of ways you can do that. You can start with R, and then it'd be theta plus or minus 2 pi k. Or if you start with negative R, then it's theta plus pi plus or minus 2 pi k. Again, if you know your circle well, I think this is more confusing than just being like, oh, I know I traveled this far on my circle. But if you don't know your circle well, this might be an easier way for you to do it. I would recommend you just learn your circle. Questions so far, guys? Okay, next section down here, we're going to plot the points and then label it in 2 other ways. So I want you guys to try to do this. Plot A, B, C, and D. Just put a dot and label it, A, B, C, or D. And then come up with 2 other labels. And it says one with a positive R and another with a negative R. Okay, so try to do those 4. Check in with your neighbor. See if you've got it. How are we doing, guys? Good. Eh? Getting there? Maybe. Give me another couple of minutes. Oh, you're just struggling with thinking of other ways to label it? So, like the first one's 5 pi over 3. You know, your other labels are going to be like the over 3s. You just have to figure out, is it positive or negative pi over 3, 2 pi over 3, 4 pi over 3.
It's just taking like so long.
Just need a little refresher with the circle. Are we ready, guys? All right, let's look at them. So first one, 4 pi over 3. So I know I'm counting out to that fourth ring. 1, 2, 3, 4, maybe. There we go. And then I know 5 pi over 3 is in the fourth quadrant. So I'm going to go around. It is this guy right here. So that is point A. Okay. If I stick with positive 4, I think the easiest way is with a negative angle. What would the negative angle be that puts me at 5 pi over 3? Negative pi over 3. Okay. Now, if I change the radius to a negative 4, that means I'm starting over here. 1, 2, 3. Starting over there. So how far am I traveling to get to that point A? 2 pi over 3. If you did the negative angle, it would have been negative 4 pi over 3. Okay, so there's lots of ways to name these. Anybody questions on that first one? Let's try again. All right, 4 negative pi over 4. That's really close to where point A was. So there's point B. All right, so again, sticking with the positive 4. You know it has to be something over 4, one of your angles over 4. What is the fourth quadrant over 4? Yeah, so that's one way to name it, 4, 7 pi over 4. Then if I go to negative 4, again, I'm over here. I'm traveling, you know, more than one quadrant away. It's essentially the second quadrant. So what would that be as my over 4? 3 pi over 4. Again, if you like the negative direction, that'd be negative 5 pi over 4. Okay, lots of ways to get there. Again, I just think of the circle. I do not go through the process of going, all right, let me take theta, let me add pi, let me subtract 2 pi, but like, to me that feels like a lot. But again, I know my circle. So, know your circle or be able to add and subtract your angles. All right, negative 4, 0. That's where my x was here. 1, 2, 3, 4. Stick with a positive 4 to begin with, I guess. What do you think, guys? If the radius is positive 4, what's my angle going to be? Pi? What else could it have been? Negative pi? Okay. We'll go with 4 pi. If I do negative 4, what are you going to tell me? 2 pi, yeah, or negative 2 pi would have worked. Okay. All right, negative 6 pi over 3. So we're out another 2 rings here. And then, so I'm starting left. So pi over 3 puts me down here. There's point D. Did you guys do okay plotting them? For the most part? Okay. All right, let's do positive 6. Do you guys see that's the third quadrant? What's my over 3 in the third quadrant? 5 pi over 3. Sorry, 4 pi over 3. I can add. Okay. You could have done negative 2 pi over 3 if you like that. That's fine. If I go with the negative 6, I've already done pi over 3, so I've got to go backwards. So I'm going backwards quite a ways. How far is it? Yeah, negative 5 pi over 3. Okay. All right, we do okay? Yeah, question.
So are you not allowed to use the same line coordinate or theta coordinate for multiple ones?
Well, it says rewrite it, so if you're putting the same, you're not really rewriting it at that point. Yep. But there are lots of different ways you could write it.
Yeah.
Technically, there's infinitely many ways you could write it. So, all right, let's keep going, guys. All right, so that was plotting and labeling our points. Now we're going to look at converting from polar to rectangular or rectangular to polar. So let me draw you a little picture here. If I draw this little first quadrant triangle, there's the theta I'm talking about. We would label this side x, y, and r. And make this a little right angle. All right, if I asked you what is the cosine of theta, based on just this little picture, what would you tell me? X over r, good. If I then said solve that equation for x, what would x equal? Yeah, r cosine theta, right? We would just multiply by r. So if you have an r and a theta from your polar coordinate, you can take r times cosine of that angle to get the x component for a rectangular form. Okay, so that's what we'll put in the little box here. X is always equal to r cosine theta.
Y is r sine theta?
Yep, because if we start with sine of theta with my little triangle here, that would be y over r. And then if you solve for y, you're exactly right, it is r sine theta. Okay. Hopefully it's fairly easy to remember because you know cosine always represents x and sine always represents the y. So what you'll be given is a problem like number 1 here. I'll tell you the polar point is 6 pi over 3. That means r is 6 and theta is pi over 3. And then I just want you to convert to rectangular. So I just use the formula. X is going to be equal to r cosine theta. So that would be 6 times the cosine of pi over 6. So what is the cosine of pi over 6? Root 3 over 2. And what is 6 times root 3 over 2? Close? Yes. 3 root 3. Good. You got that. Okay, then for the y, I do the same thing, but with sine. So 6 sine of pi over 6. Well, what is the sine of pi over 6? Yep. 6 times 1/2. Oh dear, 6 times 1/2? 3. Hopefully that's not the hard part today. Okay. So you've done the work, but don't leave your answer like this. I actually want you to put it in a rectangular ordered pair. So you would say your answer here is 3 root 3, comma, 2. Three, not 2. Here, I'm laughing that we can't divide and I can't divide. There we go. It's always good to have an idea in your head of what quadrant this polar point would be in. So I know like 6 pi over 6, yeah, that's in the first quadrant. And then my rectangular point that I got is also in the first quadrant. That's good, that makes sense. Like this next one, if I think about -4 and then negative pi over 4, that's in the second quadrant. So I want to make sure my answer makes sense with that when I convert it to rectangular. So guys, I want you to try 2 and 3. Convert them to rectangular coordinates. Talk to each other, work together on this, see if you've got it. All right, did you guys agree with your neighbors? Yes. Okay, what did we get for number 2? Good, -2 root 2, 2 root 2. Again, makes sense. That's a second quadrant answer. I like that. Anybody need me to walk through that one? Okay, all right. And then number 3, what did we get? Good. Okay, and that is a fourth quadrant answer, and 5 300 degrees is in the fourth quadrant, so that again makes sense. So we're okay with going from polar to rectangular. Not too bad, right? Plug it into the formula, pretty easy. Well, again, easy if you know your unit circle. Okay, when we're converting from rectangular to polar. first thing I want you to do is actually make a little sketch. Just plot your point again so you have in your head where it should be located. That'll help you with your r and theta. To find r, you're just essentially using the distance formula. Really, you're just finding the hypotenuse of that little right triangle. And then theta, we're going to look at tangent and figure out, okay, make sure the theta makes sense with the quadrant that our point is in. So let's go through the first one together here. So I've got 2, -2. So I'm going to make just a little sketch. 2, -2, that's down here in the fourth quadrant, right? You can even draw yourself a little picture if you want to. -2. R is what we're going to look for, converting it to polar. All right, so 2 squared plus -2 squared is going to give me r squared. Again, you can think distance formula, you can think Pythagorean theorem. It's the same. Yeah. You sure? Okay. All right, so when I do 2 squared plus -2 squared, what do I get? Okay, because it starts as 8, which does simplify to 2√2. You are correct. Square rooting that. We do want to simplify our radicals, so that is 2√2 for r. Okay. Not bad, we found the radius. Now we have to find the angle. We need to find the theta. So I know tangent of theta. You just said it there. Remember the angle we're looking at is in here, that little theta. Would be -2/2. So I want to know, when does tangent equal -1? Now, you can go through a lot of different things with that. If you're actually doing inverse, it's only going to, you can only think about a restricted part of it. Just look at it and go, okay, I'm in the fourth quadrant. Like, this is why you draw the picture or plot the point. So you can visualize, I'm in the fourth quadrant. Where does tangent equal -1 in the fourth quadrant? The over 4, so what is it in the fourth quadrant? 7 pi over 4, yes. So we can say this is 2√2, 7 pi over 4. There are other ways you could label that. You could absolutely say 2√2 negative what? What angle? Yeah, negative pi over 4. If you really wanted to, you could say -2√2. I don't think you're going to think this way. And then 3 pi over 4. I think one of the first two is probably how your brain's going to work. You want to make sure you read the directions on problems like this, because sometimes I'll say convert to polar and theta has to be between 0 and 2 pi, or between -pi and pi. Like, I'll give you a range for where theta has to be. So you want to make sure that your theta actually matches whatever I'm asking for. Okay? But if I just say convert, I would accept any of these answers. All right, you guys try number 2. Don't do number 3 yet, because that's obviously like a weird calculator one, and so don't do this one. You're not going to have calculators, so we'll skip that one for now. We're back to no calculators. I know. Yeah. It's all the thing. It's over there. Yeah. Ignore that.
This cosine resolved for cosine resolved for what? Yeah. Tangent to the angle against one. Because you have to do with that. So tangent
It's the right idea there. All right, guys, walking around, it looked like we did pretty well. Definitely visualize what quadrant you're in. So negative x, negative y. I know I'm somewhere down here in the third quadrant. I think you guys were okay getting the radius of 2. And then when you're doing the tangent of this, it's where does tangent equal root 3? That's the over 3. So now you have to think of the third quadrant over 3. So 2, and then that's going to be 4 pi over 3. You could have also said 2, negative 2 pi over 3. You could have done negative 2 pi over 3. Negative 2, negative 5 pi over 3. Okay, so lots of ways to label it to get to that same spot on the graph. Questions so far? All right, we okay, guys? Are you still alive, Lauren? Maybe. Okay, let's turn the page. So we've converted points. Now we're going to actually convert full equations. So we're going to start with turning it from a polar equation to a rectangular equation. So over here, instead of steps, I'm going to cross that out and call this stuff we know. What was our formula for x when we were going polar to rectangular, all that good stuff? Okay, good. What about y? Okay. What about, are we okay with this, that x squared plus y squared equals r squared? We know that, right? Little version of the Pythagorean theorem. Because of that, then, we also know that the square root of x squared plus y squared is r. The reason I'm listing all of this out is when you're converting equations from rectangular to polar or polar to rectangular, what you're doing is trying to either get rid of the r and theta by substitutions or get rid of the x and y by substitutions. So you're just using all these little pieces to plug it in and simplify and try to turn it into the other version. Okay? And first, is everybody okay that down here the square root of x squared plus y squared? Are we good that that does not equal x plus y? Or did you think that that equaled x plus y? Let me show you why. Let's say I have 4 plus 9. That's square root of 13, right? If you think I can take the square root of the individual numbers being added together, does that work? Is 5 square root of 13? No. Okay, so I just want to make sure this is a very common algebraic mistake that people make. They're like, oh, square root of 2 things squared. Like I'll say this, square root of x squared plus 4. People will write x plus 2. No, no, not a thing. Okay, don't do that. Can only square root the factors. All right, so what we're doing with all of this, this first one here, we have r equals 4 sine of theta. Now, I could substitute just for the r, but then you're going to have a square root of an x squared plus y squared, and you're still going to have a sine on the other side. That's not really going to be very helpful. So what I'm going to do is multiply both sides of this equation by r. I will then have r squared equals 4r sine of theta. Okay. Now I want to try to do some substitutions. What is r squared equal to? Okay. I know I have the 4 over here, but that's okay. I can just leave the 4 there. What is r sine of theta? Y. Yep. So I now have x squared plus y squared equals 4y. Technically, if all I say is convert, you have converted because there's no longer an r or a theta in there. But we're going to do a little more with this because this is an equation that I could sort of simplify a little more. So I'm going to do x squared plus y squared minus 4y, leave a little space, equals 0. Does anybody have any idea what this is an equation of? No? What do you think, Kabir? What did you say? A circle. Yes, this is the equation of a circle. So we're going to put it in our standard form for a circle. We have to complete the square to be able to do that. The x squared is fine. I don't need to do anything with that. But the y, I have this 4y that I'm adding to it. So let's review completing the square. I'm only looking at the y part when I do this. I'm kind of filling in this. The coefficient on y. Hello. Oh, you're fine. I take that coefficient and I divide it by 2. and then I square it. So what is 4 divided by 2 squared? Okay, that's the magic number I'm adding there and to the other side of my equation. All right, guys. Okay, so the x squared is fine. You have now completed the square on this y term. So you've created a perfect square trinomial. So it's now going to be y minus, because that was the sign in the middle there on the 4y. And then the square root of 4 is 2 quantity squared. If I actually took y minus 2 times y minus 2, I would get to that y squared minus 4y plus 4. And then it's going to equal 4 on the other side. All right, are you with me on completing the square? Yeah, the radius is 2, yes. And that's what you would tell me. So some of these I will ask you, like, what is this the graph of? And you have to be able to recognize that's a circle with a center here and a radius of this, okay? We will not do any conic sections beyond circle because we haven't done conic sections yet. So this is a circle. Do you guys know where the center of this circle is? 0, 2, good. And the radius is 2. This side over here, the 4, that's r squared. So the square root of it would be 2 radius. So all of that is your conversion answer. Now, every single one of these is not going to be a circle that requires completing the square. Some of them you're going to convert, you're going to substitute, and you're going to have this really ugly thing with a bunch of x's and y's, and you just say, okay, that's now converted to rectangular. That's okay. All right. I think we'll do the next one together as well. So I know it says you try now, but let's do this one together. So I've got r equals sine of theta plus 1. Any guesses as to what my first step might be? Yes, multiply by r. So I will have r squared equals r sine of theta plus r. We definitely want to multiply by r in this one because the sine of theta, without having the r attached to it, you can't do anything with it. You don't have any sort of substitution. So that's how you know I definitely need to multiply by r. Then I can substitute. So what is r squared equal to? Good. So I've got x squared plus y squared equals, what's r sine theta? Y plus, what does r equal? Yes, square root of x squared plus y squared. Guys, that is not the equation of a circle, okay? That is just an ugly rectangular equation, and you're done. You don't have to do anything else with that. All right. Questions on that one? Much simpler on that one. Okay, let's go down here and try going the other way. So we're starting with rectangular now, and we're converting it to polar. So that means we want the r and theta in there. We do not want an x and a y in there, okay? And usually the directions that will go along with the converting are that you need to solve for r. So add that in there. So we're going to convert and solve for r. Okay, so I've got 4xy equals 9. The 4 I will leave alone. What do you think I could replace the x with? Exactly, r cosine theta. What am I going to replace the y with? Good. No? Okay. So I'm going to rewrite this as 4r squared cosine theta sine theta equals 9. Okay, the next step I think is not easy for you guys to see. So just watch what I write and make sure it makes sense to you that yes, this is actually still equivalent. So I've changed it to 2r squared 2 cosine sine. Does it make sense that that's equivalent to 4r squared cosine sine? Okay. Do you recognize anything? Yeah, what is that 2 cosine sine? What is it? Which formula? You guys are like, we know it's a formula. Yes, sine of 2 theta. So I now have 2r squared times sine of 2 theta equals 9. I'm going to go up here then for a little more room. Okay, we've obviously converted. There's no longer x's and y's in here. We're just simplifying as much as we can. If you didn't recognize that and it's just a free response answer and you just kept going and solved for r, it's technically okay, it's correct. The reason being able to see things like that is important is if it's a multiple choice question and I've got this sine of 2 theta going on in the answer and you're like, I don't know where that comes from. Like you have to be able to see the different possible substitutions that you could put in, okay? All right. I said solve for r, so we still have to do that piece. So how do I get the r squared by itself? Yeah, I'm dividing by that 2 and the sine of 2 theta. So it is not going to be a pretty answer, guys. We've got r squared equals 9 over 2 sine of 2 theta. And then how do I make it just r? Square root both sides, yep. You do need a plus or minus. What's the square root of 9? 3. And you do not have to rationalize this. You can leave it as square root of 2 sine of 2 theta in the denominator. Okay? That's your answer. Not pretty at all. With these converting, does it kind of feel like you're not sure where you should stop? A little bit, yeah. It gets, like you just do more of them, it gets a little easier. And on your test, you'll have some, again, that are matching. So you don't have to figure out like, oh, I should stop on this step, I should stop on this step. You're going to match like the equation to the converted equation. Or it'll be multiple choice and it'll say, this polar equation converts to which of the following rectangular equations. Okay, so it's just being able to pick out like, oh, okay, yes, that is what would happen algebraically. Okay, all right, let's try one more. So this time we've got y squared equals 2x. Well, what can I substitute for y? So I'm going to have r sine theta, all of that squared. Okay, that's what y squared means. All right, what about 2x? What's that going to become? Good. 2r cosine theta. Okay, so on the left, this is going to become r squared sine squared theta. And now I'm solving for r. Remember, keep that in the back of your mind. I don't want to divide by r because then I've eliminated solutions. So I'm going to bring this 2r cosine theta over. So I've got minus 2r cosine theta so that I've got a 0 on one side of my equation. Okay. What can I factor out of these two? R, yeah, so I've got R, and then it'll be times R sine squared theta minus 2 cosine theta. So that's going to leave me with R equals 0. And this lovely R sine squared theta minus 2 cosine theta equals 0. To solve that for R, what would I do to solve it for R? How would I get R by itself? Yep. So I add the 2 cosine theta and divide by sine squared theta. You could leave it like that, or this is equivalent to 2 cotangent theta cosecant theta. Do we see where the cotangent and cosecant are coming from? Let me just sneak it in here if you're not. We've got 2 cosine over sine times sine, essentially, right? So the cosine over sine creates a cotangent, and then the 1 over the other sine creates the cosecant. Again, just free response, you certainly wouldn't have to convert to that final piece, but make sure you could recognize it on multiple choice or fraction. And guys, this one, this R equals 0, that's called the pole, just so you know. That means you're just centered at what we're used to calling the origin is now the pole. Okay, if your radius is 0, you're right in the center there. All right, questions, guys? Okay. You have, if you turn the page, a page that says practice, right?
Yes.
Yes, hopefully. All right, I want you to do 1 and 2. Just circle these for me. Circle 1 and 2. Four and 6. Okay, let's do those 4 right now, and then I'll get you your homework and we'll get started. Okay, so try 1, 2, 4, and 6. And then we'll go through those together in a few minutes. But try converting those. When you're converting to polar at the top there, solve for R for me, okay? Yeah.
other experts.
Plug in actual our code sign. I assume that's what she was. Let's do. I got 0 and
I know, that's why it's weird. That's why I don't like it.
Okay,
Because
so
also
let's
to
take
complete a square and but then like it's
oh, so you did
I don't know. I mean, unless that's the answer, but I don't think it is.
When you're ready to look, 1 and 2 are up here, guys.
That makes things a lot easier.
For number 1,
Yeah, remember a lot.
combining the x squared and y squared.
Yeah.
Yes, that is much easier. 6?
How do you start?
It is weird. I'm going to go through that one. How do we do on 1 and 2, guys? Yeah, Robert? Oh, okay. I thought you were asking a question. Sorry. 1 is fine now that you see the x squared plus y squared part? Okay, yes. I know I didn't tell you to do 5, so you can ignore that. But there's 4 when you're ready. You didn't have to do 5. Y plus 5 over 2, yes. That one's a circle. So you do need to complete the square on number 5. And guys, I'll just scroll down so you can see 6. I'll explain 6 in a minute.
I know. I was thinking like, you like sign or like whatever, but then you don't have the X. So
Right. Again, I'll explain 6. But I'll give you a minute. Are you ready for 6? Let me just walk you through it. So 6 obviously looks completely different than anything else that you did on this page. You just have that theta equals pi over 6. Well, if I'm trying to convert it into rectangular where I have the x and the y, the thing that I know that has an x and a y is tangent. So I would think about tangent of theta equals y over x. Like that's something I know. I know the theta is pi over 6, so I can substitute that in. So I've got tangent of pi over 6 equals y over x. What is the tangent of pi over 6? And if I wanted to solve this equation for y, yeah, so root 3 over 3x is equal to y. That is converted to rectangular. When we get into graphing lines and circles in polar coordinates, you'll know that anytime you see theta as pi over 6, it's just the equation of a line through that angle pi over 6, and so your slope is whatever the tangent of that angle is. Okay, but that'll be next. All right, guys, questions? Pass out the homework packet. If you think of a question, let me know. And guys, there is a hole puncher in the back if you need. So if you open it up, the cap here was a little weird and smudgy. But your homework for 8-1 is just this front page in there. Okay, the back of that's actually homework for you. This is all you have for next class. I will walk around and check your homework, like to see that you did it. Okay, so it's a little different than the math-based grading. It's did you do it or did you not? Okay. So make sure you stay on top of the homework.
It's just this one page.
Yep, just the front of that. The back of it's 8-2. Yeah, it'll be posted on Schoology too. And then if you have questions on any of them, we'll go over it.